This is EDUC4703U, Teaching and Learning, Problem-Based Learning. This is Session 3, Video Clip 4. This video clip is entitled Learning Theories, Constructivism, and Connectivism. The analysis questions for this video clip are as follows. Number 1, what are the characteristics of each of the stages of cognitive development in the genetic epistemology theory? Be aware that what is given in the video clip is only a very brief overview. Number 2, according to Piaget, how do people learn? Number 3, how is genetic epistemology related to social and radical constructivism? And number 4, what is inductive thinking and why is it used extensively in Western society? The discussion in this clip follows the categorization of epistemology theories introduced in the last video clip. In the present clip, we'll concentrate on the rationalist side of the organizational chart rather than the empirical side of the discussion as we did in the last clip. Quoting from learningtheories.com in 2008, the humanism page then, humanism is a paradigm that emerged in the 1960s. It focuses on human freedom, dignity, and potential. A central assumption of humanism, according to Hewitt in 2001, is that people act with intentionality and values. This is in contrast to the behaviorist notion of operant condition, which argues that all behavior is the result of the application of consequences, and the cognitive psychologist's belief that the discovery of knowledge or constructing meaning is central to learning. Humanists also believe that it is necessary to study the person as a whole, especially as an individual grows and develops over the lifespan. It follows that the study of the self, motivation, and goals are areas of particular interest. Key proponents of humanism include Abraham Maslow and Carl Rogers. A primary purpose of humanism could be described as the development of self-actualized, autonomous people. In humanism, learning is student-centered and personalized, and the educator's role is that of a facilitator. Affective and cognitive needs are key, and the goal is to develop self-actualized people in a cooperative, supportive environment. Next theory is that of Jean Piaget, genetic epistemology. Piaget lived from 1896 to 1980, and his theory, genetic epistemology, which also deals with the origins of knowledge, explains the cognitive development of humans from birth throughout life, though the original version of this theory focused only on the younger years. The first stage is sensory motor, from birth to age 2. Infants' understanding of the world is constructed by linking sensory experiences, such as seeing and hearing and tasting, with physical actions. The second stage is termed pre-operational, from ages 2 through 7. The child begins to represent ideas and concepts with words and images. However, the child is not able to perform operations or must complete processes using physical objects. The third stage is concrete operational, from ages 7 through 11. The child begins to use logic but is limited to solving problems involving physical objects and is able to take another's point of view. And finally, formal operational, 11 years onwards. Individuals begin to think abstractly. They reason logically and are able to draw conclusions based on the information that is available. One of the primary challenges to this theory focuses on instances where individuals do not proceed from one stage to the next across all areas of knowledge, such as mathematics, language, physics, or art. In some instances, individuals may never reach the formal operational stage or level in one or more areas, and in even more rare instances, individuals who are adults in chronological age may never reach the formal operational level in any area. Movement from one stage to the next, according to Piaget, occurs as a result of two primary processes. The first of these processes is assimilation, and this is the process in which, when faced with new information within the environment, the new information is fitted into pre-existing schema, or thought structures or patterns. The second process is termed accommodation, and in this process, this is a process in which, when faced with new information within the environment, the pre-existing schema this time are modified to fit the new information. Both of these processes entail active learning, that is the modification of information or pre-existing schema by the individual, and all new learning is dependent upon past experiences and schema that are developed by the individual. Another way of describing this is that all learners actively create or construct their own individual meanings, their own individual understandings based on their own idiosyncratic ways of thinking. This is the essence of constructivism. Lev Vygotsky takes this idea and moves on with it. Vygotsky lived from 1896 to 1934, and he shared many of Piaget's understandings of human cognitive development, but he was convinced of the importance of social interaction in the learning process. Vygotsky theorized that thinking and problem-solving skills can be categorized three ways. Some skills are so difficult that even with help, learners will not be able to perform them. And secondly, other skills can be performed independently by the learner. Consequently, both of these two types of skills, so the ones that are too difficult and the ones that can be done without any assistance, will not be considered here. The third category, that is, some skills can be performed by the learner with assistance. These are the ones that we'll be discussing from here on in. Tasks or skills that can be performed with the assistance of others are said to fall within a zone of proximal development, or ZPD, a theoretical area. Theoretically, then, learners will be able to develop appropriate thinking skills following successful use when assisted by others. The others who assist may be a teacher, a mentor, parent, or a fellow student. It's interesting to note that the theory requires active social involvement of others. Ernst von Glasersfeld lived from 1917 to late last year, suggests that constructivism, since it assumes active construction of new ideas, new understandings, new knowledge by the learner, is in opposition to empiricism, which assumes reliance on sensory confirmation of knowledge. Radical constructivism goes one step further in hypothesizing that scientific knowledge, that is, knowledge about how the world works, and it's this definition of science that we'll be dealing with throughout this course. Anyway, scientific knowledge is constructed by people and not derived from observations from the real world, which is dependent upon the perceptions of the observers through the processes of assimilation and accommodation. Consequently, objectivism is called into question, because no observations could actually be made without referring to the theories or constructs, thought schemas that you already have in mind. Moving one step further then, a new theory has been proposed in the last little while by George Siemens, and this is just a very quick quote from George Siemens' 2011 description of connectivism, and you'll see the link on the slide itself. Connectivism is the learning theory for the digital age. Learning has changed over the last several decades. Theories of behaviorism, cognitivism, and constructivism provide an effective view of learning in many environments. They fall short, however, according to Siemens, when learning moves into informal, networked, technology-enabled arena. There are many principles of connectivism that are given on the link that you will see there. However, we do not have the time to go through them. It might be interesting. It is interesting and will be worthwhile for you to take a look at some of the points that George makes about his particular theory. Finally, moving on into the theoretical side of this, we want to take a look very briefly at how Popper makes sense out of all of these ideas. This is Karl Popper, and he's talking about something that he termed critical rationalism. The materials here are quoted from Burnham, 2002, Critical Rationalism, a Personal Account. The problem of induction, Burnham goes on to say, is that philosophers in the past commonly believed that achieving generalized knowledge consists of this procedure. You observe lots of isolated facts and examples, you recognize what all of them have in common, and you use that common factor to make the generalization. This is called induction. They also recognize that there is a problem with this procedure. In most cases, you can't check out every example yourself, or even find people to do it for you. How can you know that the next example, which you have not yet seen, will fit the generalization? The traditional case used by philosophers was the statement, all swans are white. How do you know the next swan that you see will not be black or some other color? And if you go to Western Australia, you can actually see black swans. Information obtained by induction can never be totally reliable. Even if it is true, we have no way of knowing that it is. Inductive logic has been important to life, as Pavlovian association embodies a kind of inductive logic. Perhaps this is because it often provides a high margin of safety. Once a creature associates its situation with pain, it will avoid that situation again, increasing its chances of survival and opportunity to transmit its genes. But it is not the basis for understanding subtle details and the connections between things. For example, the cat that jumps on a hot stove will avoid all stoves, not just hot ones in the future. Inductive thinking can have destructive effects as well. Many hateful statements are made about ethnic and religious groups that are really inductive thinking in disguise. Despite all this, inductive thinking is highly valued in Western society. If you're good at it, you will score well on intelligence tests and be admired for your high IQ, and maybe even admitted to a Mensa. But it is a blind alley off the intellectual highway. The suggested solution to this problem is to make use of both inductivist and deductivist processes. This is done by proposing hypotheses or conjectures, as Popper termed them, and then to invite their refutation. If the hypotheses are refuted, that is, falsified, they can be crossed off of the list of possible explanations for the phenomenon. This process is significantly different from the empiricist viewpoint, as proof is not required. Popper would contend that proof doesn't really exist anyway, and instead of proving an hypothesis, it is falsified. The reference for the theory part of this, inductivism and deductivism, what, is again the same paper that we used for the last video clip, that is Ferrucci, Inductivism, Hypothetico-Deductivism, Falsificationalism, and Kuhnian Reconciliation. And the clip link will be given in WebCT. Finally then, the synthesis questions for this particular clip are as follows. Number 1, why might constructivist theories provide more useful ideas regarding how humans learn than the humanist theories? Number 2, when viewing genetic epistemology and the constructivist theories presented here, what do these theories say about the nature of knowledge? In other words, where does knowledge reside? Who generates knowledge? Can knowledge be viewed as an object that can be passed between individuals, etc.? Number 3, if you took the stance of a constructivist, why would it be difficult to teach in a constructivist manner? Number 4, why does George Siemens believe that connectivism is a learning theory for the digital age? And number 5, why, according to Popper, is a reliance on inductivism not enough when attempting to determine the veracity of an hypothesis?